Good day, everyone. I'm Bob Ackerman, the Editor-in-Chief of Signal Magazine, and I'd like to welcome you to our Signal Magazine webinar titled Building Power and Scale into the Software-Defined Data Center. The move toward virtual environments is well underway, and data centers now are part of that migration. The Software-Defined Data Center offers a solution to the need for more trusted, cost-effective, and reliable architectures. Now is the time for technologists and their leadership to consider options for a data center in which networking, storage, and computing are delivered as a virtual service. In today's webinar, which is sponsored by Juniper Networks, two experts will provide an introduction to the software-defined data center, its benefits over traditional data centers, key components for effective data center virtualization, and recommendations on how to evaluate requirements and plan for an effective software-defined data center. Now, those of you who have participated in past Signal webinars know all about our modern audience interface that offers useful capabilities. At the bottom of the console are a number of widgets, especially the green Resource List widget, which you can use to download slides from today's webinar, along with Juniper and VMware white papers, solution briefs, blogs, and videos, as well as links to Juniper's LinkedIn and Facebook profiles. You also can enlarge the slide window by clicking and dragging on the bottom right. But most importantly, throughout this presentation, all webinar attendees are encouraged to submit questions electronically through the Q&A box on the webinar console. When our experts are finished with their presentations, they will answer as many questions as time permits during this hour-long session. Our first presenter is Daniel McGinnis, Senior Director of the Cloud Solutions Marketing Group at Juniper Networks. Danny has been designing and operating end-to-end network solutions at companies such as CSC, SunGard, and NASDAQ for more than 15 years. His focus at Juniper primarily has been on the company's data center, WAN and SDN technologies. He and his team strategically meld Juniper's technology solutions with customer business needs in those areas. Our second presenter is Bill Roche, Senior Manager of Systems Engineering for the Networking and Security Business Unit at VMware. Bill works on expanding network virtualization and SDN technologies within the federal government, with a focus on enhancing data center security. His experience at VMware includes leading system engineering efforts for the intelligence community, in which business as virtualization redefined the data center. So with that, I'd like to turn the presentation over to Daniel McGinnis. Danny?
Thank you very much, Bob. Hi, everyone. Dan McGinnis here from Juniper Networks. First and foremost, thank you very much for taking the time to join us today to learn a little bit more about VMware and Juniper's partnership, and hopefully what you'll leave in about 45 minutes with is a much better understanding of VMware's NSX solution and how it integrates and is supported by Juniper's Metafabric and switching, routing, and security underlay. So with that, actually, my co-host, Bill, could you introduce yourself?
Yep, thanks, Dan. This is Bill Roche from VMware's Networking and Security Business Unit. I just wanted to thank everybody for joining today, and I think we have some very good technology to discuss as we move forward.
Great, and please, as Bob said, just to reinforce, please feel free to ask as many questions as possible, and we'll do our best to answer them, throughout the presentation and spend some time at the end. We'll definitely leave some time at the end for Q&A. So Bill, why don't you kick it off? Why don't you talk to us a little bit about the software-defined data center and what VMware is doing to modernize themselves there?
Absolutely. Thanks, Dan. So when we talk about the software-defined data center, I like to look back a little bit about what server virtualization has done for the data center, right? And kind of expand that construct and say, when we first looked at server virtualization, it was really a consolidation play in the data center in order to gain, efficiencies around power, space, and cooling, running a number of virtual servers on one physical server. But what it ended up doing is really transforming the operational model of the data center through the abstraction, of the physical hardware. And really what VMware is looking to do with the software-defined data center is expand, that construct of server virtualization into the network and storage side and the network, stacks of the data center. So when you look at it from an industry perspective, if you look at large commercial IT providers like Google and Facebook, they've really led the charge in this area with having abstracted from the underlying hardware, and really what they're providing is at the software layer the services that they deliver, and they're delivering them at an incredibly rapid pace, right? And allows them to bring new features to market at the speed of software innovation. So that's really what we're talking about when we talk about the software-defined data center, is extending that construct throughout the technology stack in the data center and being able to deliver at really mission speed that innovation, and in many cases, be able to deliver IT at the speed of the mission. So with that, it really allows the software overlay to take advantage of the underlying hardware and making sure that we can put in place the most performant, reliable, scalable, and cost-efficient hardware, really underpinning that software-defined data center. And when we look at the advantages of that software-defined data center, what we're seeing is really this speed to mission concept that I spoke of. And the pressure that we see, kind of harkening back to, what these commercial providers are being able to deploy into the market with such rapid speed, that's now become the expectation for internal IT, is to deliver and almost to compete with that commercial provider. And really, when you look at the software-defined data center, that is one of its main goals, is be able to deliver IT at the speed of the business or the speed of the mission, right? And by having everything be software-defined, it allows you to build in the automation that really enables that speed to mission. So overall, those are some of the advantages that we describe when we're talking about the software-defined data center. And in reality, we're moving away from a really tightly coupled hardware-defined architecture where a system relies on each individual piece of the hardware in order to be able to deliver the service. So, as we do that abstraction, we're orchestrating that hardware, but we're not necessarily having to upgrade the entire hardware stack in order to deliver a new capability, because we're able to deliver that in software. Okay? So probably the best quote that I've heard about the software-defined data center was delivered by a general that we were working with around this concept. And the reason that they were looking at the software-defined data center technology was, his statement was that his current IT stack does not deliver IT at the speed of war. Right? And I thought that was an interesting comment. His perspective is they were putting missions in place and soldiers on the ground, and then their IT was having to catch up to actually that deployment. And that is why they were actually looking at the software-defined data center as a solution to have IT keep up with the speed of war. All right. So moving on, and in reality, I like to use this phrase quite a bit, which is the better together phrase you see in this slide. And really in a lot of joint operations, right? And joint operations can take many forms. It's hey, why do these technologies go together and work well together, right? And when I look at that, I look at it from a technology perspective, and I look at it from traditional IT silos, right? So those silos typically fall into two categories. I usually put them into the people and technology categories. And in my own experience, having run a data center for the DoD in the past, we typically have our sort of system silo, our network silo, our storage silo, and in many cases those silos are not communicating with each other, right? So part of the vision of the software-defined data center is being able to orchestrate not only the technology but the people and processes around delivering the software-defined data center. And my own analogy that I've experienced is when we first introduced server virtualization in this DoD data center, I had my network manager come to me a couple months after we did that and ask me, what's going on? Why of my requests for network changes, skyrocketed by like 400%, right? And his basic tenet was we can no longer keep up with the pace of change that's happening on the software or on the system side. And what was very interesting to me is, we had done the automation and sort of changed the paradigm around system deployment, right? But we hadn't done that yet on the network side, and he was feeling that pain, right? So as much as we've tried to sort of integrate those teams in the past with, say policy or just, joining those teams together in one form or another, we really see this software-defined data center and the integration with what Juniper is providing around, this underlay hardware technology tying into the software-defined data center is the construct that's going to enable all of this sort of automation to happen and the alignment of what is traditionally IT silos. And in general, what we've seen is in order to have a successful software-defined data center implementation, it requires bringing all the stakeholders to the table like we've really never seen before. And when I say that, I mean in many cases when we're looking at a successful deployment of the software-defined data center, we're bringing the network team to the table, the systems team to the table, the security team to the table, and the storage team to the table. And, Juniper and VMware have a long-standing history of, a technology alliance and making the products work together. And that's really what we're going to talk about today is, the ability to kind of put the VMware and the Juniper pieces together in order to realize the software-defined data center. And ultimately, what I see is Juniper is really at the forefront of leading this technology charge in integrating with the SDDC. And what I again harken back to what we've done on the server virtualization side is when that first happened, you saw an adaptation happen on the sort of system side where the folks, the technology vendors or the server vendors sort of adapted to this new construct. And Juniper really has led that effort. And what we're seeing is the ability for the SDDC to take advantage of sort of the better performance, the more availability and higher utilization and scalability of the Juniper fabric that is underlying the SDDC. So ultimately, and we're going to kind of break this down a little bit between what VMware is providing and what Juniper is providing in this joint technology effort. On the VMware side, with the deployment of the software-defined data center, we really are able to start programmatically addressing the needs within the data center. Okay, so when we're deploying systems, right, we're no longer just deploying virtual machines, right? We're actually deploying virtual machines with virtual networking components and with virtual storage components, right? And we're basically doing this a lot in a policy-driven manner, right? And really looking at from a speed to deployment perspective, exponentially increasing, or I should say really decreasing the time to mission when it comes to deploying a system. Okay, and what that makes up in the VMware construct of the software-defined data center is the underlying compute virtualization as well as the NSX virtual networking. So the NSX product is the virtual networking component of what VMware is providing for the software-defined data center. And what's really interesting is as we're providing that as the overlay on top, the Juniper Metafabric architecture is actually underpinning that, communicating with it, and actually providing some great capability as well as visibility into that construct. So I'll pass it over to Danny just to talk about the Juniper Metafabric architecture as it applies to that software-defined data center.
Thanks, Bill. So for those of you that I hope most of you have actually at least heard the term Metafabric or Metafabric architecture from us, but to give you just a high-level conceptual overview, so we launched Metafabric about 2 years ago, and actually when we first did, a lot of people were probably slightly confusing because it had that term fabric in there. So they said, oh, is this the next generation Q fabric? And this was before we had virtual chassis fabric. For us, Metafabric is much bigger than that. Think of Metafabric as more of a blueprint or a vision of a holistic way to look at how Juniper sees solving the problem across not just one data center, but multiple data centers, and incorporating all of the appropriate WAN technologies, data center interconnection technologies, connectivity out to your campus and branches, and even the integration in hybrid cloud scenarios where you connect to managed services and services that are stored perhaps in a remote cloud. So for us, there's three principal or core guidelines that we tried to stick to with MetaFabric. The first one is simplicity. And for us, that was everything around how do we make our products easier to buy, how do we make them easier to operate, how do we make them easier to demo, how do we make sure that there's more automation out of the box and packaged in a way that's actually usable without having to have teams and teams of people be able to leverage the capabilities. Juniper's really had automation in its heritage. I've been a Juniper customer. Actually, I've been at Juniper for 6 years now, but I was a customer much longer than that. And I've been doing network automation most of my career. But the problem in previous years has been that automation only came to very qualified candidates. And I think one of the things you're starting to see with things like the advent of NSX, you're seeing what VMware pretty much revolutionized what happened in the world of server virtualization. And Bill just talked about, if we just look at simple change control, move adds and changes, a new move comes in, the server team could had the bragging right to say that they accomplished their piece in a matter of minutes quite often. And VMware really set the stage for that. The network has often been the bottleneck, even though the change itself may only take minutes. Quite often change control gets in the way of that because it's, mostly done by humans. It's not automated, and it can push out, from days to weeks to months, depending on the complexity of different people's change control policies. So anyway, for Juniper, that was the first one: how to just start to simplify that piece as much as possible. Just operating, building, and maintaining a network. The second tenet or the pillar for us to focus on was openness. We very much believe as being a networking vendor that it's important that our customers have choice. And so being able to use as many standards-based protocols as possible and open APIs so that we can integrate with other best-of-breed technologies out there, VMware being one of the most obvious and important ones in our technology alliance ecosystem. And then the last piece is really around being able to be smart. And this is one of the areas that I see probably some of the most innovation coming. So think about being able to automatically react to network anomalies or to application performance issues, and then to take it one step further, move into the world of proactively reacting on trends. So something as simple as in your hosted data center, this particular switch or this particular portion of the data center becomes very overburdened, or there's a spike in network performance, and being able to automatically signal back to VMware to say, hey, why don't we move some workload over to this portion of the data center, and do that completely automatically with no human intervention at all. And this is the area where we're really starting to get into as we get over the next year or two. So anyway, with MetaFabric, it's around our switching architecture, it's around our routing architectures, as well as our security architectures, and then integrating them with the rest of the technology ecosystem that's out there across multiple data centers and throughout the WAN. And then for NSX, in order to help network virtualization actually become a reality and be able to provide the same SLAs and operational simplicity that we've come in traditional IP networking, being able to have that on-ramp and as well as give the operational views and the topology views so that we can easily understand what is happening in the overlay and in the underlay. And we'll talk all about that a little bit more over the next few minutes.
Thanks.
So I'll hand it back to you. Yeah.
Great. All right. So, we went one forward here. So yeah, we're going to dig into a little bit more about the virtual networking with NSX. And when I look at a traditional data center today, right, we're going to have a number of components that exist. We're going to have that physical network that's actually in charge of forwarding the packets throughout the network and communicating, right? And really the prerequisite here for NSX is that we have a network that can forward IP or an IP backplane. So I always say if we're running AppleTalk or IPX, we're out of luck, but I'm pretty confident in saying that we have the vast majority of folks running an IP backplane at this point. So then on top of that, we have our physical servers, right, that are actually, plugged into that physical network, right? And then on those physical servers, right, we have a hypervisor running, okay? And, that hypervisor, the NSX technology can work with the VMware hypervisor as well as several others. And what we're actually doing is we're embedding within the hypervisor this, for lack of a better term, a network hypervisor that provides this network virtualization or SDN capability, okay? And then we're hosting these VMs, within the user space on top of that hypervisor. And ultimately, what we're doing is we're creating virtual networks within the overlay construct that we've spoken about. And what we're doing there is we're actually able to deploy logical components like virtual switches, distributed logical routers, load balancers, and firewalling capability virtually within the hypervisor and provide all of that functionality. And really what it is it's very similar to the server virtualization, is that we're providing a faithful reproduction of those services so that the system that's consuming them has no idea that it's actually a virtual construct that it's consuming. It just knows that it's receiving the, switching, routing, or load balancing or firewalling services from the network, right? And with that, we've really pulled a lot of the intelligence and decision making into this virtual network piece, and we're using the concept of a controller to actually, keep track of the information of where the VMs are and the MAC addresses and make those decisions. And ultimately, we're then actually relying on the underlay in this case to be that highly performant, reliable, and scalable backplane that is required. And what I like about the design here is it's really freeing up our network architects and network engineers to design that network, that underlay network, to be what it was supposed to be, which is the most performant and reliable network that it should be. And in many cases, we're taking out some of the unnatural acts or gymnastics that are done on the network today in order to meet some security needs, right? So moving on from that, the very interesting capability that this network virtualization or SDN capability has brought to the table is the opportunity for enhanced security, right? And when we look at what we're doing in sort of a centralized security stack today in many of our data centers, we're going to do a little bit of animation here. We're actually, taking a packet on this VM, right, this blue dot that we see, and we're actually forwarding it all the way through, both the virtual and physical network out to a centralized security stack, right? And that's where we're making the decision, is this allowable traffic, right, based on our security policy or firewall policy. And in many cases, it's actually, the number's about a little over 30%. We're routing that traffic all over the network, and this is where I kind of talk about the sort of unnatural network acts, only in order to be dropped, right? So over 30% of that traffic is just being dropped based on firewall policy, right? So not a real efficient use of network resources. And in reality, we're pushing packets all around the network that they shouldn't even be really permitted on the network, right? So what's very interesting with the NSX construct is when you deploy this virtual networking capability, you're actually able to deploy a firewalling capability that sits within the hypervisor and makes the security decisions closest to the source that's actually generating the information, in this case, the virtual server. Right. So when you look at that same construct, this green VM is actually going to, create a flow or create a packet and send information, and the actual firewall policy is sitting within this virtual network construct and making the decision that, hey, we're going to actually drop that packet at its source before it ever actually moves into not only the physical network, but also the virtual network. It's actually never going to touch either one of those things, right? And what's really unique about this, and I'll take one step back here, is with the deployment, say, through a cloud management platform of this, security policy, one of the big challenges when server virtualization came into the environment is, hey, we just enabled portability of all our virtual machines, and what that did is really broke a lot of our security policies because these VMs potentially are moving all over the place. And what's nice about this technology is with NSX, when you actually move a VM, the security policy actually follows that VM, right, and is enforced with the move, right? And then the other problem I think this really solves is when you look at a traditional sort of firewall rule stack in an enterprise data center, it's a pretty lengthy set of rules, right? And usually what you see is those rules are never really deprovisioned, right? Because there's this fear of what will happen if I deprovision the wrong rule and will I open up the network to some kind of vulnerability. So what's nice about the NSX technology with this virtual firewalling is when you actually deprovision that VM, the firewall policy is deprovisioned at the same time, okay? So you're actually automatically cleaning up that firewall rule list as you go. All right? And then what we're going to kind of get into is actually the part where we're understanding that, hey, this virtual networking construct is absolutely going to have to tie into the physical network because there's, as much as we at VMware would like to believe that everything is 100% virtualized, there are going to be workloads out there that are running, on bare metal. We usually pick on the databases that are still, running on bare metal. And what we're actually doing here is we're actually working with, Juniper to actually create what we call a VXLAN tunnel endpoint gateway. And what the VXLAN technology is it's actually the overlay encapsulation technology that we're using to actually, route the packets through the physical network, right? And the actual Juniper system has an understanding of what we're doing there, right? And we can actually act as a gateway to the physical network because it understands the VXLAN technology and it acts as an endpoint to de-encapsulate that packet when it comes into the physical network, right? And overall, this is the type of thing, kind of going back to the beginning of, when I talked about the technology partnership, where Juniper's ability to understand what NSX is doing from an encapsulation perspective, to actually leverage some of the control messaging that's coming out of NSX, and really be able to join the two technologies together to sort of realize this software-defined data center vision in tying everything together and actually being able to orchestrate both the virtual and physical assets in the data center together is what enables the realization of the software-defined data center, right? So with that statement, I'm going to turn it over to Bob for just a poll question to the audience about the integration of, the networking and virtualization stacks.
Okay, thank you, Bill. Okay, this is where the audience gets to join in the presentation briefly. We have a poll question. How well integrated is your network infrastructure with your server virtualization infrastructure today? Tightly integrated? Partially integrated, or little to no integration? And while we're waiting for the results to come in, Bill, I'd like to ask, what do you think is holding back more organizations from going this route that you just described? The software-defined data center seems to make a lot of sense.
Yeah, that's a great question, Bob. I think in reality, we're dealing with, in some cases, sort of the organizational, way of doing things in the past and the silos that I spoke about before. And what I am seeing is sort of breaking down and moving that initiative forward is really the customer need, right? So we see in many cases the customers that are driving this need for speed to IT, deliver IT services or speed to mission as what's driving the move to the software-defined data center, because in reality, the automation and the tie-in and integration of both the virtual and physical networking components are really the only way we're gonna get there overall. And what I see in many cases is as Danny mentioned before, and kind of my story about my network manager at the time, is the next logical step in this virtualization journey is really providing that network virtualization piece and automation in order to, catch up that network piece to where the server virtualization piece has been.
Okay. All right, let's have a look at the poll results. 20.6% are partially integrated. 71.4% say they have little to no integration. No one says it's tightly integrated. Danny, I'd like to give you a little equal time on this. What do you think of these results? Do they surprise you?
No, actually, maybe they surprise me because there's more partial integration than I would have thought. But a slight bit of humor there, I guess, or maybe not that funny. No, as Bill just alluded to, as I've been alluding to, I mean, every customer I talk to, actually, I'll even give a different perspective. I think that the customer problem has gotten so much more complex because there's so many dimensions and there's so many dynamics to it. When I used to work on a network engineering team or a network architecture team, we used to be able to make a decision about the network very independently. You knew a little bit about what the application was doing. You knew a little bit about what the direction of the storage team was. And you could go and make a very, hey, this is the highest performing router, the highest performing switch. It has all the features I need, et cetera. To some extent, a lot of those things have almost become prerequisites. And now the decision has gotten this extended complexity because it's essential that the storage team, the compute team, the systems team, the network team are all jointly making that decision. If not, what we like to say at Juniper is you kind of run yourself into these dead ends. It's like, oh, we made a decision over here with no knowledge of what was happening in the other silos. And now we're stuck in a place where we can't support some of these other initiatives. And so, no, there was definitely, absolutely a lack of integration, but it is becoming more and more essential in order for people to move forward that these integrations exist. And frankly, I think that's why Juniper and VMware very much value each other's partnership. I think we at Juniper know that certainly NSX and network virtualization and a lot of the orchestration and automation that VMware brings to the table is essential to helping customers move into this world of software-defined and cloud. And in the reverse, I think VMware knows that in order for them to be successful, it's important that they have very tight integrations so that the network is completely aware of what's happening above it or over it. So if we're ready, I'll move on to the next set of slides here. All right, so for the next 10 or 15 minutes, I would like to just really focus on three major technology integrations that Juniper is focused on having with VMware and vice versa. The first one is what we started to allude to around the VTEP gateways, and for Juniper, this comes in two forms. The first is the traditional VXLAN gateway bridging. This is essentially having L2 gateways that can bridge a VXLAN VNI with a traditional VLAN. The second one, and this is a very unique differentiator for Juniper because there's not really anyone else focusing on this in the industry, so is what we call our universal SDN gateway routing capability. So we'll talk in a little bit of detail about that. And then lastly is a lot of the virtual and physical management and analytic integrations that we have to help from an operations perspective. So let's talk a little bit about gateways here. Bill just introduced the concept in the last slide that he showed you, and I'll sort of elaborate on that and try to talk a little bit more in depth about how it actually works. So the concept of it's inevitable, right? We know that even if we make the majority of our data center SDN enabled or VXLAN enabled, there's still going to be some portions of the data center that just don't have the capability, or nor would it make sense to make them run these additional protocols. High performance databases, high performance compute servers, x86 servers such as mainframes. All of these things just don't make sense, or most likely will not be SDN or VXLAN enabled in the near term. So what you need to have is some translator essentially that can understand both sides. So Juniper has worked very hard over the last year and a half with VMware to use OVSDB, which is a management plane / control plane protocol that allows us to talk directly to their controller and import and export layer 2, layer 3 routing information so that it makes the controller be able to have a holistic view of everything that sits behind or in the legacy space. The other thing that allows us to do is allows the NSX controller to actually control or modify the code on the Juniper switches and routers as well. So where we sort of add an extra, I would say an extra set of differentiators to this as well, to go above and beyond just the L2 use case is, think about when the workload that sits outside of the NSX realm is in a different subnet. So because we have programmable silicon, Juniper uses its own custom silicon in our MX series routers, our QFX 10K, which is our most recently announced high-density chassis, as well as our EX9200. This gives us the ability to do some things that are not capable in a lot of the merchant silicon platforms, like even what's available in our QFX 5100. So being able to route between subnets, being able to connect isolated SDN overlay domains, meaning if you had two completely disparate NSX environments that for some reason from an administrative or a security perspective need to be isolated, being able to bridge those two together. And I guess for us routing guys and our network guys, think of this as like a route redistribution, so OSPF into BGP. How am I, leaking routes from one OSPF area to BGP? And then the other thing that we can do in the same exact box is interconnect directly with IP, MPLS, VPLS, EVPN. So rather than having to, rip off the VXLAN header, go into a native IP and then up to a IP router, in our MX, in our 10,000, we can go right into the DCI use case. So VXLAN tunnel terminates on top of a MX or QFX 10K and goes right into your MPLS, EVPN, DCI data center interconnect. A couple of the benefits that we get here, right? So line rate, virtual to physical connectivity. So one of the things, because this is done in purpose-built silicon, we don't really have to deal with the worries of, degradation or the unknowns of the scaling and the performance pieces that go along with it. We can do this hitless, so even down to our 1U top of racks QFX 5100s, we're able to do hitless in-service software upgrades on those boxes, and anything with the gateways can take advantage of that as well. Certainly best-in-class networking, so a lot of customers will tell us that they want to peer when it comes to their IGP, peering with a hardened router. That's something that they usually feel more comfortable with when they're peering with a router that perhaps is already in their network. We support this technology inside of our virtual chassis fabric. We support it in Junos Fusion, in our OpenClass technology, which is basically just an IP fabric that's managed, that has no or interoperable with pretty much every vendor out there that supports native IP, as well as QFabric. And in many cases, this is already the underlay or the DCI on-ramp or off-ramp. So we a lot of customers, without even having to swap out their hardware, are able to take advantage of these integrations. So that covers layer 2 VTEPs, and it covers our universal SDN gateway. The other piece that Juniper is very much focused on is around the whole concept of management, orchestration, and all of the analytics. And we help provide this mainly through our Network Director technology, along with all of the APIs and the underlying connectivity that needs to happen. So with Network Director, even outside of NSX, the integrations with vCenter, if you're not aware, and these are things that many customers may not know about. They don't realize that they can already take advantage of these integrations. So today, even if you're not in an NSX shop, with Network Director, we have connectivity with vCenter. So you can do things like view VM and server details and the topology. You can verify connectivity and troubleshooting. So think about this, the network operator being able to have a subset view of perhaps what's inside of vCenter. Being able to determine what VMs are using what amount of bandwidth up to the switch and across the network. Being able to manage changes, so as a server moves as a result of vMotion in VMware, being able to take things like your VLAN settings and quality of service settings and perhaps firewall filters that may be applied to a given port and moving them around as a VM moves completely automatically. So the other part, mainly we're here to talk about NSX today, so some of the newer integrations that we've enabled inside of Network Director are now being able to look at what the VXLAN topology looks like. So if you just simply state it, think about when you move to a world of network virtualization. And Bob asked this question a little while ago. What's preventing some customers from adopting some of these newer technologies? Quite often, I find is that everyone's usually enamored by the art of the possible, and they start to look and say, "Wow, this is really cool." And then all the evaluation comes, and the operations teams get involved, and they say, well, okay, it may actually add some value. We may be able to do something new, but how do we support this? How do we provide the same SLAs that we are already providing today? And then so this inherent fear kind of kicks in, right? Oh, it's too new. It's not ready yet. And I think that this is where VMware and Juniper working together really starts to add a lot of value, because one of the big problems you have is, well, all my network traffic is now encapsulated inside of this tunnel, and I can't see it the way perhaps I used to see it. So being able to actually display graphically what the VXLAN overlay topology looks like by integrating with vCenter and with all of the underlying switches brings a tremendous amount of value, or perhaps puts the operations teams at ease. And in fact, it actually makes their lives a whole lot easier. So network virtualization brings along with it a whole set of value add features and technologies. And then I think the visualization, I'll give you a way to relate. As a network operator or network engineer, how many of you have probably walked around a data center, almost spent a day trying to set up spam ports and sniffers, trying to track down a certain traffic flow to figure out what path it was taking in your data center? You're at a point now where you can do all of that from a simple graphical user interface with some of these newer technologies, as long as the integrations are there. And that's, I think, some of the most important pieces. And then the last thing we'll talk about is, hold on, let me just talk about from a solution benefit perspective. So one of the big things here is just the ratio of your network to server operational expenses for the resources that are being used there. Having that integrated virtual visibility that I just alluded to. And for us, Network Director is very much a single pane of glass network management tool. So not even without the integrations with VMware, being able to troubleshoot your underlay, being able to do your design, your turn up, facilitate all of your move adds and changes. And then the integration with vCenter kind of brings it all together from a network operator's perspective, being able to troubleshoot end to end. Then the other thing that I mentioned that we didn't talk about yet is what we do around the world of analytics. Frankly, I think that the world we live in, if you think about big data, in the healthcare industry, big data has, having tremendous amounts of data and being able to analyze it and correlate it is probably the most important evolution that's happening in healthcare when it comes to saving lives, because there's this aggregated or this disparate set of research, and you want to bring it together. In the world of financials, right, every credit card company that we use wants to aggregate our data to look at our spending habits and trend it so that they can, do something to make money off of that information. In the world of networking, our big data is about analytic data from as many points as you can get it, from as many touch points as you can get it from the network, and then correlating that data to either automatically be reactive or proactively make decisions about certain trends that may happen. So I am a firm believer that when you look at networking solutions, as well as the solutions that you look at with VMware, the more and any other vendor that you bring into the mix, it's important to see what these integrations look like, because the data that is combined from each one of their areas of expertise is really what can help you be very, rapidly troubleshoot and respond to problems in your network. So things like VXLAN ping and traceroute and VMware path visibility, being able to get metrics around, what type of traffic flows are in your network, being able to, stop when there's a bad seed or perhaps someone's been compromised, and being able to shut that down in seconds rather than in hours because you immediately know where it is. These are things that Juniper is heavily focused on and partnering with VMware and NSX on to give ultimately our joint customers a better experience. And so with that, that was the last slide that we had. Again, I thank all of you for joining. I certainly will think it's time we can open it up to Q&A. Bill or Bob, I don't know if there's anything else you wanted to add in.
Well, sounds like Bill is okay, so let's open it up to questions. Now,
Great.
Again, folks, use the Q&A box to submit any questions. Got some already in the queue, but we have room for more, so please feel free. First question I'm going to ask is, if we have a legacy environment that is not Juniper, do we have to jump into SDN immediately with VMware and Juniper, or is there a graceful migration?
I would say I'll probably at least start with the answer. So if we have a legacy environment that is not Juniper, do we have to jump into SDN immediately with VMware and Juniper, or is there a graceful migration?
Mm-hmm.
So I would say I don't think anyone should jump into SDN. Is my opinion. I think that SDN is one of those things that you have to consistently evaluate what the return on your investment is. I quite often see a lot of customers, and Bill, just because, and Bill, maybe you want to clarify this point too, is NSX doesn't mean that you have to implement SDN. There's certainly a lot of other values that come along with SDX than just the network overlay piece.
That's absolutely correct.
Yeah. And so I think the network overlay aspect, meaning are we going to have a tunnel that potentially traverses our environment, you have to look at the pros and cons. And that's where I said, our customer's job is not getting any easier, right? I mean, we're trying to make it easier by, jointly validating and testing the integrations. But no, I don't think you have to jump right into SDN. I think what is my suggestion when you look at your underlaying your infrastructure, and probably some of the most successful customers that I've seen navigate these newer technologies are the ones that say, I know I want to get my network refreshed. I know that I'm going to want to do something, new and revolutionary in the years to come. So I want to look at a network that I know has all of the features and will continue to develop and to innovate in the direction that the industry is going. Juniper, certainly we don't have a crystal ball. We have good insights into what is happening in the future, and it's our commitment to stay as open as possible, and know that these integrations need to happen over time. So, anything you want to add there, Bill?
Yeah, I would say, from sort of the VMware perspective, I think it's a good question because we see it from customers quite often about, hey, do I have to do the full boat, of sort of SDN, out of the gate? And very clearly, I think the answer to that is no. And in many cases, what we see is sort of the driving force behind NSX initially is actually the security use case, right? To be able to provide that distributed firewalling capability that I spoke of and secure an environment, in the short term, and then enable you to move to the, SDN and network virtualization technologies with that platform, that NSX platform that you have in place. And I agree with Danny that as you're looking at this from a long-term perspective, when you're looking at the physical network refresh, you wanted to be able to pick the vendor, like Juniper, that is in touch with what is happening both now and in the future to enable, that automation piece as you get into the SDN portion.
Yeah. Okay, let's move on to another question here. Some of the challenges that my agency is dealing with are around provisioning new services quickly and then bringing them down when the project or mission is completed. How does the SDDC deliver this automation?
Yeah, so this is Bill. I think I can take that one because, to be honest, we see this use case almost every day. And really, from what the SDDC enables to deliver that automation it's a number of things. But typically what I say around this is, hey, we've been deploying, say, virtual servers now for a while, right? Maybe a decade or so. And really what we're now enabling with a front-ending sort of with the cloud management platform, whether it's, VMware's vRealize Automation or another cloud management platform, is not only are we going to deploy the system, right, and we're going to actually deploy, not just VMs, but an integrated system, in a multi-tiered app fashion. But we're going to deploy the virtual network components along with that system, right, including things like load balancing and firewall rules all together, right? So when you look at having to, provision a new service quickly and then, basically destroy it and bring up, say, another service, right? That cloud automation platform is really the key, and tying in the network virtualization piece with NSX so that you're not only deploying the system, but you're deploying all the network constructs to go with it so that when you hit that deploy button, it's becoming operational right out of the gate. And you're not, I always say, if you have to file a help desk ticket to do the network and the storage piece of your cloud automation platform, you're not actually doing automation. And really, I think that's what SDDC brings to the table, is automating that network and storage piece.
Okay. Next question. You might have mentioned this, you might have discussed it, but the question is simply, what are the prerequisites to installing NSX?
Yeah, so this is Bill. So I did mention at least one piece of that, which is, we have a physical network, an IP backplane that can forward IP packets. So that's definitely a prerequisite. The other piece is actually increasing the MTU size to 1600. And the reason for that is for the VXLAN overlay, right? So we add, some headers on the packet, and we need to be able to, move those headers throughout the network. And a clarifying point on that is, and it kind of relates to the first question about having to do, SDN everywhere all at once, is we find, some environments where they're going to implement NSX and they're going to, change that MTU side for a portion of the network in order to start that, network virtualization journey. So that's really the prerequisites, is that IP backplane and the 1600 MTU size.
Okay. Got a couple more NSX questions here. This one, does NSX have a dependency on a particular cloud management platform?
So the answer to that is no. We work with, NSX is a very, open API driven product, right? So, we can interoperate with our own cloud management platform, vRealize Automation. We can use things like OpenStack. There's a number of other cloud management platforms that we see customers using NSX to automate the network provisioning with through the open API. And that's actually one of the things I really like about, the NSX product, is it's able to insert in an environment they may have a pre-existing cloud management platform without having to change that environment.
Okay. Let me do a non-NSX here. Can you elaborate on some of the enhanced gateway options that you were referring to with USG?
Yeah, I guess that one, this is Danny, I guess I'll take that one. So I sort of look at gateways in four particular use cases. There's an L2 use case, and that would be when workload that sits in the same subnet as, so basically I have workload that sits inside of a domain that is using network virtualization, like VXLAN, and then you have workload that sit outside of that, right? That's when we need some sort of a gateway. So the first one is the L2 only. They both sit in the same broadcast domain. I tend to find that is not, although it's one of the most commonly things talked about, when you start to pull back the layers, not too many customers tend to have their workload in the same subnet sit in the cloud or inside the network virtualization area and outside of it. Usually people want to recover from years and years and years and years of IP subnetting mistakes, or they've exhausted most of their IP subnetting, so they kind of start new. So that quickly kind of brings on a few more use cases you need to consider. One would be L3, when you have two workloads that need to talk to each other that are in different subnets. Perhaps a web server has been added, has been SDN enabled, and the database server that it speaks to has not. Most likely that is an L3 use case. The third one is SDN to SDN. A little less common at this point in time, but I think as we see the evolution of SDN and network virtualization more widely adopted, I think you'll end up where, although sometimes I'll use a language translation experience. So although they both talk, so gateways are like, a person that is speaking English trying to talk to perhaps a person that is speaking French. They need a translator if they don't understand that language. SDN to SDN gateways is like when somebody is speaking two different dialects of French. Even those guys need a translator because they may not understand each other. And then the fourth use case is one where, SDN to WAN. And there's a couple different examples there. So when you're inside of a network virtualization space, how do you talk to the internet? That kind of plays back to the layer 3 use case. But how about when we have to get in and we want to do a layer 2 bridge across multiple data centers? I need to come from a VXLAN tunnel, need to go into an EVPN or a VPLS tunnel, then I need to get back into a VXLAN tunnel on the other side if the other remote side of the data center is SDN enabled. And so that creates a whole other set of use cases. And then also out to your campus and branch. How do you go right to an IPsec tunnel or to a GRE tunnel if you're using the internet perhaps for extending out to your remote locations? And so that's where there's no merchant silicon in the market today that can do anything above layer 2. We're still some time away from these other 3 use cases. And I'm proud to say that, because Juniper uses custom silicon, even an MX that is in your network today can support these other use cases just via software upgrades. These are things that we've added to our software over the last 12 months or so. And I absolutely think it very much complements, the on-ramp and the off-ramp of SDN-enabled solutions.
Okay. Another NSX question. This one's a little more technical. How are the NSX distributed firewall rules managed for microsegmentation?
Yeah, so very good question. And in reality, we're doing things a little bit differently than what we're seeing today with a sort of centralized, firewall in a, central security stack. So we're actually centralizing the management of the firewalls, the distributed firewall, because each actual hypervisor is running this firewall functionality. And we're managing that through the centralized NSX manager, but we're actually deploying the firewall rules out to each hypervisor. And what's really nice about sort of that distributed model is we are only enforcing those firewall rules that actually apply to the VMs running on that specific hypervisor, right? So you don't have this firewall rule sprawl existing where you have to go through 1,000 rules to actually find the one that applies to that particular VM that's trying to communicate across the network. And the other, I think, advantage there is you're gaining what I would call the power of distribution from a firewall throughput perspective. Because you're doing the firewall at each hypervisor, you're actually adding to throughput by leveraging the physical NICs in each server. And typically what we're seeing is if a server has two 10-gig NICs, every server you add to the NSX distributed firewalling capability, you're adding 20 gigs of firewall throughput.
Okay. Well, that concludes our Signal Magazine webinar for today. I want to thank our two experts for their presentations, and thanks to all of you for joining us. Our presenters will try to respond directly by email to any unanswered questions in the queue. You can link to the archived version of this webinar, along with previous Signal webinars, on the Signal Magazine website at www.afcia.org/signal/webinar. Thank you again, and have a good day.